So 13 feet is 4 meters, right?
Yep.
Okay.
So the trees are planted, mosquito, planted 4 meters apart, roughly a meter wide. One thing that I propose for growers that are planting under cover, where the water is going to come into the orchard, like a flat roof, is to plant on a berm or a raised bed, and to have subsurface drainage. Because we know that cherry cracking happens with water on the fruit, like those, but it also comes from water in the soil through the root system.
Evaporation.
Yeah.
Unless the soil is sandy or it's got a really good drainage.
Really good drainage, right? So if it doesn't have really good drainage and you have the potential for significant water coming in from the rain, best to have some sort of system to drain it out. So we've started doing that with our high tunnel systems now. You know, they're domed, so they shed into the leg row. We'll put the drains in along the leg row. This shows what we call a TSA, the central leader type tree. And if we've got the slits in the flat roof, every 4 feet, or that's what, 1.2 meters, you can see what portion of the tree might get wet. Just a little portion out here, but a significant portion of the tree here. Significant portion here, just a little bit here. And ultimately we'll go out to the flat roof and see if the trees are still wet out there. You'll see they're quite wet, even under the flat roof, because if the water comes through the slit and hits an upper branch, it deflects, and then it comes down and it hits the next set of branches and deflects again. So whereas you may have one spot that's coming through, it spreads into a cone type wetting pattern as it comes down through the canopy.
But in terms of spacing and architecture, the one that you would really recommend for high density and good, let's say, production or high density would be the TSA always undercover. That would be your...
No. Yeah, I don't want to suggest that TSA is the best of all of these. The point I was making back there was looking at the TSA alone, at the spacing we planted, the TSA on Gisela 5 was better than on Gisela 6 or on Gisela 3.
Okay.
But I wasn't saying the TSA was better than the UFO or the SSA or the KGB.
Okay. That has to do with the spacing.
We have more data to collect before we come up with that.
With that conclusion.
So for a flat roof, this is the SSA, or this is the UFO or the SSA. So different spacings, so roughly 2 meters or 1 meter. Different trees per acre, different trees per hectare. But you can see, I think that we can arrange fruiting wall type canopy architectures so that the rainfall, when it's directed through those slits in the flat roof, would avoid the bulk of the tree. So I just wanted to give you the view of 2 different possibilities, because I think this is the way, if you're going to go with a flat roof in an area that has potential for rain, it's the main way to go, because you keep the majority of the tree dry, and there's just no guarantees you can keep the majority of the tree dry in this situation. If you're in a place where it rains once in the summer and you're just wanting to protect against that one odd occurrence, you know, you can train the trees a little more widely. So the ideal thing would be to capture as much light as possible with a V-type training system. So the next research trial that I want to look at is the Espalier Oval Rainier versus the V UFO. So you've got a UFO, typically you plant this way and you grow these uprights. And they're 20 centimeters apart. And that's about the amount of light that you want to have the leaves intercepting. Well, if you make those uprights 10 centimeters apart, but you put this one this way and the next one that way, and this one this way, the next one that way, you've got much more light interception compared to a standard UFO, and you don't have to worry about where the rain's coming through because it's not coming through at all. So I think that gives you the opportunity to increase your overall production because you're capturing more light per hectare. And actually, you know, I showed you those 2 diagrams. I've got like 10 diagrams of all kinds of different systems, including the V that Ben just mentioned.
In terms of spacing, now that we've gone through the tree architecture, in terms of spacing, what would you think it'd be? Because under one of Cravo system, you want to be really productive. I mean, you want to optimize the space as much as possible.
That's right. So you want a precocious rootstock that will fruit as quickly as possible.
Yeah.
Yeah. So coming back to, if I was to invest in an X frame, big expense. So I need to start paying the bank back as quickly as possible. This is where the different vigors of the rootstocks comes into play. With a more vigorous rootstock, you can plant farther apart because it's more vigorous. It'll fill the space at wider spacings. It takes fewer trees per hectare. With a more vigorous more dwarfing rootstock, you need to plant them a lot closer together. And you need to make sure that you filled that space when your fruit starts to come in, because when the fruit starts to form on the tree, it diverts the resources away from growing new shoots. So the goal is to have the space totally filled, or be very close to filling at the time that you come into fruiting. So our goals in that trial were to fill the space at the end of the third year. And the third year would be the year that you first come into fruiting. Significant fruiting. So, using a Gisela 6 or a Gisela 12, both being the most vigorous Giselas we currently have, but also being very precocious, so they will fruit in the third year. I would plant them at a distance that, well, if you're going to go with the standard UFO, depending on how big your nursery tree is, you plant it so the next one overlaps. So at the time of planting, you filled your horizontal space. Then your strategy in year one and 2 is to fill the vertical space. So if you're going with an X or a V, I think you let those grow for about half the growing season straight up, because that's the maximum growth rate you'd get, and then you start bending them over and attaching them to the wire. Then